All right, now that we've learned a little bit more about what gene linkage means and what its consequences are, let's see how we can use some data to make meaningful sense of recombination and really use it to figure out where genes are located on a chromosome. This is the first problem in your homework packet on gene linkage, and I thought it would be useful for us to go through it together. In this problem, I have two different types of fruit fly. Recall that whenever we're doing linkage problems in here, we're crossing a heterozygous fly with a double recessive fly, and that's just what we'll do in this class. So here I have a wild-type fruit fly. Wild-type, recall, is heterozygous for both the gray body color and the normal wings here. And it's being mated with a black vestigial fly, which I know is a double recessive based on the readings and the information in the packet. And then we have the four phenotypes show up in the offspring. So the first thing I've done already for you is I've gone ahead and set up a key for the two different genes we're considering here, which are body color and wing type. And my first question asks, what are the genotypes of the parents? Let's set this up like we'd normally set up a cross by first giving the parental phenotypes. Okay. I have two phenotypes. One is the wild type, which I know is heterozygous for both body, gray body color, and normal wings. And we're crossing that with a fly who has black body and the vestigial wings. Okay, these are the parental phenotypes, what they look like. Now underneath, let's write out the genotypes. Heterozygous for gray body. Well, we know that capital G is dominant, and that's gray. So I have big G, little g, and I have big L, little l, because we're heterozygous for both traits here. The other parent is black vestigial, which I know is a double recessive, little g, little g, little l, little l. So those are the genotypes of my parents. And I'll record that right here. Now the next question asks, how many offspring do I have in total? For this, it's a simple matter of adding up the information given to you here in the problem. 778 offspring plus 785 plus 158 plus 162. If we add all four of these different phenotypes together, we end up with a total of 1,883 offspring. It's a lot of fruit flies there. The next question asks, which offspring's phenotypes are recombinant? Recall that recombinants do not look like their parents. So in this case, I have two parental phenotypes and two recombinant phenotypes. The wild type and the black vestigial are my parental phenotypes, and the black normal and the gray vestigial are my recombinant phenotypes because they do not look like either of their parents. They are a combination of the two. So black, normal, and the gray vestigial are my recombinant phenotypes. If you want to just look at the numbers of offspring produced, you'll notice that the wild type flies and the black vestigial flies have a much higher number of offspring produced. This should set off little red flags for you, saying that because these numbers are occurring in so much greater quantity than the other two, that those must be the parentals. This also should set off flags saying, aha, these genes are linked because I'm not seeing an equal 1-to-1 to 1-to-1 ratio between the four offspring phenotypes. So now if I want to figure out how many of the offsprings were recombinants, I just need to add up the 158 black normal flies and the 162 gray vestigial flies, which gives me a total of 320 recombinant flies. The next step is actually calculating out the recombination frequency. How often is this happening? There's a very simple little formula we're going to use for this, and it is just the number of recombinants divided by the total number of flies, the total offspring. Times 100. So in this case, I have 320 recombinant flies divided by 1,883 total flies times 100 gives me a number of 16.9% or 17%. Now, great, they show recombination, crossing over happens 17% of the time with these flies. So what? What can I do with this information? Well, we know from Stewart-Vaught's work that a recombination frequency of 1% also corresponds to a distance on the chromosome of 1 map unit. So if I apply that, a recombination frequency of 17% means that these two genes are separated by 17 map units, 17 MUs. That tells us the actual physical distance on the chromosome between the genes for body color and wings. Then as we start to accumulate more and more information, we can start to map each of the individual genes found on this chromosome that may also be linked with the body color and the wing type. You're then going to continue to apply this information throughout the rest of the problems in section 3.1, looking at gene linkage. Go ahead and try those. Check your answer keys in class. And if you have any questions, please let me know. Good luck.